There are several ways to find solutions to polynomials. We can either factor or use the quadratic formula. So I'll show both methods with this problem. The first step is the same either way. We want to move terms of the polynomial set equal to 0. So in this case, we'd move 16 by subtracting it from both sides, and we'd be left with the polynomial 3x squared plus 2x minus 16 is equal to 0. Let's try the factoring method first. So to factor, we multiply the x squared coefficient by the constant term, which is negative 48. And then we want to find the factor pair that, when added, is equal to 2. So we could try negative 2 and 24. Could try negative 4 and 12. But the factor pair that ends up working is negative 6 and 8. Because negative 6 times 8 is negative 48, negative 6 plus 8 is 2. So we split the 2x into negative 6x plus 8x, and we rewrite the other two terms, 3x squared and negative 16. Now we group the first two terms, and the greatest common factor of those terms is 3 and x. If we divide 3x out of 3x squared, we're left with x. If we divide 3x out of negative 6x, we're left with negative 2. Then we group the last two terms. 8x minus 16, the GCF is 8. So we divide out an 8, and we're left with x minus 2. So then the factored form is the x minus 2 that remained each time, and then the GCFs are the other factor, 3x plus 8. So this is the factored form. Really, at each step, we had this polynomial set equal to 0. So now to solve from this factored form, we can take each factor and set it equal to 0. So if we take this factor and set it equal to 0, that's x minus 2 equals 0. To solve that, we add 2 to both sides and we get the solution x equals 2. The second factor is 3x plus 8. So we set 3x plus 8 equal to 0. To solve that, we subtract 8 from both sides. We get 3x equals negative 8. Divide by 3. And we get x is equal to negative 8 over 3. So our two solutions are x equals negative 8 over 3 and x equals 2. So now we'll show that we get the same answers using the other method of the quadratic formula. So this time we'll use the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And our a, b, and c are a equals 3, b equals 2, c equals negative 16. So plugging into the quadratic formula, that would be x equals opposite b is negative 2 plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 3, times c, which is negative 16. All of that under the square root, all over 2 times a, so 2 times 3. After we have it set up, we simplify. That would be negative 2 plus or minus the square root of 4 plus 192 all over 6, which is negative 2 plus or minus the square root of 196 over 6. The square root of 196 is 14, so this is negative 2 plus or minus 14 over 6. So now the plus or minus means that we have a positive and a negative possibility. The positive possibility would be negative 2 plus 14 over 6. Simplifying that, negative 2 plus 14 is 12 over 6, which is 2. And then the negative possibility is negative 2 minus 14 over 6, which is negative 16 over 6, which reduces to negative 8 over 3. So we see that using the quadratic formula, our solutions are negative 8 over 3 and 2, the same as when we used factoring to solve. So either method works for this example.